how would you solve? You would either factor or use the quadratic formula. This is not factorable. So we would use the quadratic formula, where this is A, this is B, and this is C. It is going to be a big number, which is why right here we're just going to say use quadratic formula, because I'm not going to give you something that hard on the test. I'd like you to get more than one problem worth. Okay? Why would we do what? Because in order to solve for, okay, if I would have simply taken the fractions and made them all have a common denominator, you can't just add them together now. You have to solve for x, and so now you have x's in the numerator and you have x's in the denominator. So you're going to have to start flipping stuff, multiplying, dividing, factoring. It makes it a lot more difficult. If you simply just get rid of the fractions in the beginning, then your equation is a lot easier to solve. Right. From here, you would use your quadratic formula. Okay? What does absolute value mean?
Wait, how far it is from 0?
The physical distance from 0. Very good. Absolute value refers to a physical distance, which means it's always positive. Now what we're doing here is we're trying to figure out what are the values of x that when we plug it into that right there, we can get 15. Well, since the answer to this is inside absolute value, I could get positive 15 and I could get negative 15, right? So the way I solve this is I set it equal to a positive 15 and a negative 15 and find both of those values. When you add 3 to both sides here, you get 2x equals 18. Divide by 2, one of your x's can be 9. Because 18 minus 3 is 15, and the absolute value of 15 is 15. Here we add 3 to both sides, get 2x equals negative 12. And we get that x is equal to negative 6. Don't start. Because look, 2 times negative 6 is negative 12, minus 3 is negative 15, but the absolute value is still positive 15. Absolute value equations, you set it equal to both the positive and the negative. What if it's not in a nice, pretty package?
You have to make it a nice pretty package.
Divide by 2.
You isolate and you don't undo division for you don't divide first, you undo minus 5 first. Okay?
Can you pass the 5 over to the other side?
Yeah, we're gonna pass it over. Okay? We're gonna add 5 to the other side.
Then you divide by 2.
Then we're gonna divide by 2. And now we're at the point where we say, okay, set x plus 1 equal to positive 10 and negative 10 and find your 2 possible solutions. So x is equal to 9 or negative 11. What is the absolute value of that? Or let me ask you this. What does x have to be so that the absolute value can be negative?
Negative. Not,
No solution.
Why?
because the answer is negative.
Because absolute value refers
Can't be
to a
negative.
physical distance, and a physical distance is never negative. Alright? This is a square root equation, and we're going by the same idea as the absolute value. Just like we had to isolate the absolute value, we need to isolate the radical. Not yet.
Plus 6.
Add 6 to both sides.
First, we want to isolate the radical. Otherwise, we're going to have to square the radical minus 6 times the radical minus 6 and do FOIL with that, which is just crazy. Okay? Now, however, to get rid of the radical, we square both sides.
That's a big number.
Yeah, about that.
Really hard to know.
3 and 19.
And then you subtract 5.
Someone used to do good on these tests. Oh, I didn't talk to you this time. What grades you put on my things?
Power School is all messed up, and until they're finished messing with senior grades, I'm not even touching it.
Because it says I have 860 on homework. So.
Right. I have people with 15s on tests and 600% on quizzes, and yeah.
Bro, my grade down.
666%.
All right.
Oh,
You got an 800 on the test.
166.
oh, clear.
6x squared equals 54.
Square root.
3.
Square root.
Same principle here. I have one term with a variable in it. I'm going to isolate that variable.
Take away the square root. Square root.
The reason I'm going to divide by 6 first is because 6 is not being squared with the x. Now, if this had been present, then I would take the square root first. Okay, but that wasn't present. So, from here I take the square root of both sides. And remember, anytime we have to take the square root of both sides, we show both the plus and the minus, and this is why. Again, we are looking for all possible numbers that we can put into those parentheses and get negative 9. Excuse me, positive 9. 3 squared is 9. Negative 3 squared is also 9. Patrick, I need you to stop talking. How many terms have x's in them? 1. Only 1. So just isolate that x. No, you don't have to solve it as a quadratic.
Divide by 6.
Can you subtract 6?
Subtract 6 from both sides. No. Then divide, but because I'm saying 6 and writing 6 and it's supposed to be 2. Sorry.
Now divide by 2.
So x equals
Okay. Oh, but there is.
square root.
Oh, the answer would be x squared.
It's imaginary.
I squared.
Plus or minus.
We had to take a square root of both sides, so we show both the plus and the minus. There's a negative under the radical, which is an imaginary number, and 5 cannot be reduced any further. Here we take the what? Cubed root of both sides. Now, do we say plus or minus?
No.
No.
No,
No, because the minus will come out negative.
exactly. Only for even.
It's a positive negative.
Only for even root.